electrically charged. We now know that all objects are neutral, electrically neutral, which means that they contain equal amounts of positive and negative charges. Now, some negative charges are moved, if some negative charges are moved from one object to the other. In fact, what I did here is moved some negative charges from my jacket to this pen. So what happened? The pen now has an excess amount of negative charge, and therefore we say the pen is negatively charged, and my jacket now lost some electrons. When the jacket lost some electrons, it has some excess positive charge. So we say the jacket is positively charged and the pen is negatively charged. So it is possible that we can charge an object either positively or negatively. A positively charged object we will represent like this. Does it mean that this contains only positive charges? No. It means it contains some excess positive charge. That means some negative charges are missing. In the same way, the pen has now acquired some negative charges. It will be called a negatively charged object. We will represent it like this. But remember, the total amount of charge in the universe is a constant. Now, if the jacket loses electrons, the pen will gain them. That means the total amount of electric charge will remain a constant. Now, this is called the principle of conservation of electric charge. And this is true for the whole of the universe. Electric charges can get transferred from one object to another, but the total amount of electric charge in the universe is a constant. So if two objects form a closed system, the total amount of charge they hold will remain a constant, even though charges could flow from one object to the other. The amount of charge lost by one object will be equal to the amount of charge gained by the other object. Does it sound familiar? Well, in the principle of calorimetry, we had a similar situation. Well, how do we charge an object either positively or negatively? That's what we discussed so far today. Now, when a polythene rod is rubbed with fur, now that is another way of charging object. This is a polythene sheet. If I can rub it with fur, rub it very, very well, I'm going to rub it. If I do that, the same phenomenon can happen. Now, electrons from fur will get transferred to the polythene sheet. Now, let's see if the polythene sheet has some excess charge. Let's try and bring it close to the electroscope and see what happens. Now, you can see the electroscope is now charged. Look at the leaves of the electroscope. I have been able to charge the electroscope. Now, if I touch, you can see when I touched, all the charges disappeared. Now, what happened when I touched? My body, all human bodies are good conductors of electricity. So, when I gave an excess amount of charge to this, when I touched it, those excess charges moved to the earth through me. I am a good conductor. We say the object has been grounded. But we will talk about that as we go on. So here we got the polythene sheet rubbed with fur. What happened? Fur lost electrons. That means the fur now has an excess amount of positive charge. And the polythene gained electrons. We have a polythene sheet that is now negatively charged and the fur that is positively charged. Now, this is made possible by electrons getting transferred from fur to plastic, leaving fur positively charged and plastic negatively charged. Now, a similar situation occurs when a glass rod is rubbed with silk. Now, but the process now is slightly different. What happens when a glass rod is rubbed with silk? I have a glass rod here and I'm going to rub it with silk. Well, the result of this experiment may not be very convincing, so you need to watch very carefully. Alright, I'm going to rub the glass rod with silk. I need to probably rub it a little more vigorously. And I have the electroscope. I hope you can see the leaves of the electroscope. Alright, I'm going to touch it. You can see it's charged positively. Now, I want to show you something. I'm going to now bring a negatively charged plastic sheet near it. Alright, what is the charge on the electroscope now? The electroscope is now charged positively. You see what happens when I bring a negatively charged rod near it? You see that? Why is the leaves collapsing? Because these negative charges will drive down more negative charges to the leaves, and the positively charged leaves get neutralized. If I now touch it, well, the electroscope actually now got neutralized because the charge on the plastic sheet is negative. Okay, well, now you know how we can charge objects either positively or negatively. Now this is because electrons from glass rod move to the silk. You see, this time when you rub the glass rod with silk, the electrons from the glass rod move to the silk, leaving the glass rod with an excess amount of positive charge, and of course the silk got some excess amount of negative charge. Now, thus a positively charged object has some excess positive charge, and a negatively charged object has some excess negative charge. The Earth is a large reservoir of electric charges. Actually, Earth can absorb, take in large quantities of electric charge. That means if you touch a charged object, the excess charge in the object will flow to the Earth through your body, as I just showed you when I was discharging the electroscope. Now, that means the object will become neutral. Any charged object will become neutral when you connect to the Earth. Now, have you seen that most of the electrical appliances in your home is connected to a 3-pin? Now, one pin brings the electricity to the appliance, the other will return it, and the third connects your appliance to the Earth. You know why it is important? Suppose there is some leak that electricity gets onto the body of your electrical appliance. Then that leaked electricity will flow to the Earth. It's a safety precaution. Now, every electrical appliance which uses high voltage and current needs to be grounded, needs to be connected to the Earth. Connecting to the Earth will allow the electric charges to flow to the Earth safely. And this process is called grounding. In electrical circuit, we use this symbol for grounding. So where you see this symbol, it means the electrical circuit is connected to the Earth at that point. Now here I have a diagram on charging a neutral object by conduction. Actually, I showed you how the electroscope is charged by conduction. What did I do? I had a negatively charged object. You remember the negatively charged object I had was the negatively charged plastic sheet. this one. Now, when I brought this is the neutral electroscope. How do I know this is neutral? Because the leaves are not diverged. Now, when you touch it to the platform of the electroscope, what happens? Some excess charges will move from the charged object to the electroscope because the platform of the electroscope is a good conductor. And those excess charges then will move through the stem and to the leaves, and you can see the leaves will diverge. If you now move the charged object away, the electroscope will retain some excess charges. Now, what is the phenomenon that happened here? The phenomenon is sharing of charges. By making a charged object in contact with a neutral object, the charges from the charged object got shared. Now, but the total amount of charge in the two object system will not change. The total amount of charge remains a constant. That's right. That's something that you should not forget. Now, here is the neutral electroscope. You can see I have touched it. All the charges on it has flown to the earth. And I'm now going to charge this plastic sheet by rubbing it onto my jacket. Now, my woolen jacket come very handy actually, so I'm trying to see if I can charge that plastic sheet negatively. And of course, my jacket will be then getting charged positively. Now, bring the negative charges and touch the electroscope. You can see it has not been very spectacular. Well, there you can see the electroscope has been charged positively. Now, that means the charges has been shared. Well, let's see what happens when I touch the knob. Well, the charges have been, the electroscope has been discharged. Well, I'm trying to see if I can do that a bit more. You see, sometimes it is pretty hard because if the atmosphere is not very dry, the moment you create the excess charge, they tend to leak through the atmosphere. You see, damp atmosphere is a good conductor. There you can see there has been a good sharing of electric charges there. The electroscope has got a fair amount of charge now. Now, the charged electroscope, I'm going to touch it. You can see it's been discharged. It's been grounded. Well, so now you know how to charge an electroscope by conduction. Conduction is the process by which the charged object is made in contact with the neutral conductor so that the charges can flow. But remember, only positive charges, only negative charges are allowed to move. Positive charges are not allowed to move. Alright, so if I now charge this glass rod positively, how will now let me see if that can be done. If I charge this glass rod positively, I cannot guarantee you that this is going to work, but we will try. And if I make it in contact, you can see, yes, the electroscope really got charged, but not very spectacularly. Now tell me, how did this happen? Can positive charges move to the electroscope? Is this what happened? Think about it.